Okay, so picture this. These huge, vibrant underwater forests. Some call them the sequoias of the ocean, right? Just swaying. But they're way more than just pretty scenes. They're like ecological powerhouses, providing food, shelter.
Absolutely. And buffering coastlines, storing carbon, supporting livelihoods, and holding deep cultural meaning, too. Really vital stuff.
Totally. But then, about a decade ago, something started going very wrong. A kind of silent killer emerged. So that's why in this dive, we're using your sources to explore the vanishing forests, the mystery of the sunflower sea star. Our mission really is to understand how losing this one amazing creature could cause such a huge ecological ripple effect and what the chances are for recovery. I'm really curious to get into this.
It really is a fascinating story, like a piece of scientific detective work almost. We'll trace the effects, from this single species right through the whole ecosystem, see what happened and what it takes to maybe bring something like this back. It has really broad implications.
Okay, let's unpack the timeline then. Your sources talk about this marine epidemic. It started back in 2013 along the Pacific coast.
Yeah, from Mexico all the way up to Alaska, huge range.
And the sunflower sea star, Pycnopodia helianthoids,
Yeah.
the impact was just devastating. Populations dropped by over 97%.
Over 97%. It's hard to even grasp. Essentially, a functional wipeout for what was a really dominant species. And it was unprecedented. The crucial thing here is this wasn't like a small local problem. It was the largest marine epidemic ever recorded in the wild, period. And losing that key predator, well, that immediately set off this ecological cascade. It put the kelp forests themselves in real danger.
And for years, the cause was a mystery, right? This horrible wasting disease, lesions, tissue breaking down, arms falling off, just gruesome.
Exactly. It was gruesome and incredibly frustrating for scientists trying to figure it out. What was this thing? What's really fascinating, though, is the breakthrough came quite recently in 2025. After over a decade, researchers from UBC, Hawkeye Institute, University of Washington, they finally nailed it.
Okay, so what was the culprit?
It turned out to be a specific bacterial strain, Vibrio pectinacida, FHCF3.
Vibrio. That sounds familiar.
Yeah.
Isn't that the genus linked to things like cholera?
That's the one. Infamous genus. And this particular strain, like others in the family, it seems to thrive in warmer water.
Ah.
Which, immediately raises alarms with accelerating climate change. It wasn't some strange new disease agent, but maybe a common microbe pushed over the edge by warming conditions.
So, okay, this top predator vanishes. What happens then? What fills that vacuum?
Well, it was a dangerous vacuum. The sunflower sea stars were major predators of purple sea urchins.
Right, the ones that eat kelp.
Exactly, kelp's biggest grazers. Without the sea stars keeping them in check, the urchin populations just exploded. In some places, they reached levels more than 60 times what was normal, historically.
60 times, wow.
Yeah. Imagine these armies of urchins just mowing down everything. They created what scientists call urchin barrens, just bare rock where lush kelp forests used to be.
And that impacts everything else, I assume.
Oh, absolutely. It hit abalone, rockfish, fisheries that people depend on, and it deeply affected indigenous communities whose culture is so tied to these ocean resources. Plus, you have to remember, the sea stars were already likely stressed from climate change impacts. So this disease was like a devastating double hit.
It sounds incredibly bleak, but your sources do mention hope, a path to recovery.
Yes, definitely. Despite the scale of the loss, there is a plan. The Pycnopodia Recovery Working Group, it's this big collaboration. They've outlined the steps. And a really significant moment was in 2024. They released 20 young sunflower sea stars raised in captivity back into the wild, off San Juan Island.
The first one's back.
The very first step. A huge milestone, really, towards trying to reestablish the species.
And it's not just about putting sea stars back, is it?
Yeah.
There are also efforts to remove the urchins directly. I saw mentions from California, even Tasmania.
That's right. It's a two-pronged approach, really. Even a small number of returning sea stars can help control urchins naturally. And studies show they can even eat starving urchins, which is interesting. They can still predate even when the urchins are in poor condition in those barrens.
So they could potentially help kickstart the recovery, even in those devastated areas.
Potentially, yes. It offers a kind of natural feedback loop. But active urchin removal gives the kelp a much-needed head start to regrow.
So bringing this all together, what does this mean for us, for you listening? What's the path forward look like?
Well, the sources lay out a pretty clear path, and it's fundamentally collaborative. It means expanding that captive breeding and reintroduction effort for the sea stars. It means actively managing urchin populations where needed, It also means more research understanding the disease better, looking into kelp genetics for resilience.
Future-proofing, kind of.
Exactly. Strategies for future-proofing these ecosystems against climate change. Maybe finding or breeding more heat-tolerant kelp, identifying refuge areas. But the key word really is collaboration. Scientists, governments, indigenous communities, nonprofits, fishers, everyone who depends on or cares about the ocean needs to be involved.
It really shows how interconnected everything is. The story of the sunflower sea star.
Hmm.
It's such a powerful example of how fragile ocean life can be, but also maybe how resilient it can be too, with help.
It absolutely is. And maybe the final thought for you, the listener, is what role can we all play? How can we collectively help future-proof these vital marine environments so they don't just survive, but actually thrive for the future?
A crucial question. Because it's clear the future of our oceans really does depend on that kind of collective action.